Hi everyone. So welcome to all on Suffer Placement. So today I am starting one more interesting language, that is the Verilog HDL. I believe you already the familiar the name of the Verilog HDL. Okay. Why I'm telling this is most important course, the Verilog HDL, not of course only for the placement point of view. Okay. See, so before the coming on one by one, what are the importance of the Verilog, and what are the my motive is that why I am starting the Verilog the course. Okay, so this is the first part. Actually, if you ask me na, so just sir only explain those questions which is the most important for the placement. So then this is very simple. I will explain 30 to 30 question approximately. That is enough for the placement point of view. Okay, but my motive is not like that. My motive is I want to explain the Verilog in very well, and one day you will the feel more confident, and you can design the any digital circuit. Okay, so you can write the Verilog code from on. Okay, the my motive is that. Okay, see, just wait one by one. This is the first lecture, and one day definitely you will write the Verilog code. See, the first thing is that, so if you ask from me any basic thing is required before the taking of the Verilog HDL course. My answer is the basic thing only if you know, yeah, of course you know already the digital electronics. If you are a digital electronics, okay, electronics, if you I mean right now if you are doing MTech from any college, so definitely you already qualified the gate exam, or you have a good idea of the digital electronics. Okay, and if you are doing, if anyone is doing the BTech also, have a good idea about. Okay, so in the digital electronics, only basic thing is that you should have an idea of the digital basic. Basic means you should have an idea of the combinational circuit, like that the combinational circuit. It will help you, and sequential circuit like flip flop, like monks, half header, full header, like that counter, everything. If you have a good idea, then this is positive for you. Okay, see, just I am giving one example, and while you are taking the Verilog HDL course, the point is that suppose you already have an idea of the half header. Okay, am I right? Half header. Okay, so okay, in the digital electronics, you already idea have a the half header. Half header, it is used to add the two one bit number, and there are the two output is there, sum and carry. Okay, you already know. So just, so this is the 00 01 10 and 11. So sum is 0 1 1 and 0, and carry 00 01. You have already idea about that. Okay, so you already studied the half header. So half header, it is used to add the two one bit number, and there is a two output, sum and carry. Now, actually, earlier, what was the digital engineer the felt like that? Is there any way? Yeah, is there any special language? Yeah, is there anything so that we can implement this half header as a hardware? How can you implement this thing, the half header? Okay, so if you have a questions in your mind, sir, we have already of the C language, yeah, C plus plus, yeah, Pascals, like that. So why we need to go the Verilog HDL? Actually, I will tell the difference between them also. This language are the programming based language, and here you will write the program for anything, like to for a string, to adding two number, like that. But here we will implement the half header as a hardware. Okay, So for that, there is a special language in the 1983. I will explain one by one. In 1983, the two scientists was there, Morby and one Boyle. So these two in 1983 designed one special language for the digital circuit only. That is called the Verilog HDL. And with the help of them, with the help of them, we can implement any digital circuit. Okay. So I will explain also what are the difference between C and Verilog. Just wait. So this is the story behind it. Actually, now we want to implement every the digital circuit, especially for the digital circuit. How can you implement as a hardware? So for that there is a special language, there is a special thing, that is the Verilog HDL. With the help of the Verilog HDL, you will implement this half header circuit in the hardware. For hardware, as a hardware you will implement. Okay, so this is the point that. So for that purpose, you need to study the Verilog HDL. That's why we will study the Verilog HDL. Suppose see, Verilog as hardware. This is the hardware description language, and and the point is that it is just a language. See, it is just a language, nothing that just like a Hindi, yeah, English, yeah, C language. Just it is a language. If you study the language very well, if you have an idea of the Verilog, then simply you can implement any digital circuit. So if you have a question in your mind, sir, if I want to the implement for an analog circuit, how can you do? Can I do this thing by the Verilog HDL? So the my answer is HDL is there, but different HDL, that is a Verilog is there. So in the next video, I will tell the difference between them. Okay. So in this part, I explain this is the part one and this is the basic part. That's why I am explaining the story why we are taking the Verilog HDL course. So in the complete Verilog HDL, you will design, you will write, yeah, you will implement hardware for only the digital circuit. Okay, this is the first point and this is the single point. Whatever the story I told, if you forget, no issue. Just remember this thing: Verilog HDL is used for the digital circuit and the designing of the digital circuit. So for that, if you want to design the any circuit like mux, like flip flop, like counter, like any logic gate one day, so you need to study. Okay, one by one I will tell. Okay, see. So so in this part, the point is that the importance of the Verilog, why I am telling this is most important and why you should take the Verilog HDL course. See, the everyone have a goal to enter in the VLSI industry. That's why you are doing the MTech in the VLSI industry. Okay, and that's why you took the course EC most in most of case. So the your motive is to enter in the semiconductor field. Okay, the first point. That's why I'm telling, in the future, if you are becoming the digital, the digital design engineer, especially for the RTL engineer. So you need to write the code for architecture. So in the company, in the VLSI industry, you have a block for any project. I am not going in the deep. So you need to write the Verilog code for RTL engineer. Okay, so if you become the the digital design engineer, RTL engineer, if you have a very long idea already, then it is very helpful. And definitely if you enter in the industry, that being of time, you will have a more idea compared to now, right now. Okay. And also, actually right now I am working in the Cadence in AMS verification profile. So if you are becoming the AMS means this is the analog mixed signal. This is the analog mixed signal verification, mixed signal. Okay, so for that, if you have idea of the Verilog, it is also helpful. Okay, just I am telling why you should have an idea of the Verilog HDL, because ultimately your motive is that by taking the placement, you want to enter in the VLSI industry. And of course, if you have an idea of Verilog, then definitely it is very helpful. And one thing is there, I will tell in the briefly. So I mean for the designing of the analog circuit, we have an analog A. Sorry, the Verilog AMS for both digital and the analog circuit. In the next part, I will tell just some difference. Okay, so this is the building of all HDL. There are so many HDL is there. Verilog, then the Verilog A. I mean Verilog A. Then we have Verilog AMS. I mean. The VHDL language is also there. These all are languages there. So this is the basic building of all HDL. If you have an idea of HDL, then definitely because of that, the Verilog A is used for modeling of the analog circuit. Analog circuit, whatever you study, the yeah, of course, transistor level is also there. A schematic based. The op-amp you can base by the help of the transistor. Okay, but HDL also. Why the difference? Actually, see, if you have a op-amp, so op-amp you can design with the help of the schematic based. I mean, suppose you have a op-amp. So op-amp ultimately it make with the help of the transistor. So transistor, so you can design the transistor on the basis of schematic also, and by the help of the HDL also. So single circuit. What are the difference? I am telling just on the 5 point. Okay, and 4 point is there from placement point of view. So now right now your motive is only for the placement, so this is the most important point. So I will tell you definitely, if you are attending the any interview now, in most of case the interviewer will ask the question from the very log. Okay, and this is the very simple. My belief, definitely you can give the answer of the very log question easily. Okay, so just I mean no worry about that. Okay, so this point I'm telling, HDL have a many advantage compared to the traditional schematic based. Suppose I am giving the one example. Suppose you have a inverter. Okay, so this is the inverter. Okay, so this is the input, and this is the output, and this is the ground, and this is the VDD. I am not taking the output node capacitance here. Okay, just you know already. So this is the inverter. If you give the output A, input A, it will get the A bar. If you give 0, output 1, 1, 0, 1. So actually, sorry, actually in the industry, what happened, this inverter you can design with the help of the transistor. I mean the transistor level. Transistor means basically we will talk here only for MOSFET. BJT is also there, but BJT is very less. In most of case we discuss the only for MOSFET. So the this box we can design with the help of the transistor only. This is the transistor. So here I design the same inverter circuit with the help of the transistor. If I design any circuit with the help of the transistor, that is called the schematic. That is called the schematic. But the same inverter we can design with the help of the Verilog HDL and Verilog A also. But here I am telling the Verilog. So this inverter you can design with the help of the HDL. That is the Verilog HDL, and simply you need to write the code. I mean, don't worry about the code. Just I am writing here the piece of code. Y, and I am taking the input A. Okay. So that's why I'm telling. So compared to if you simulate these two things, schematic based and the HDL based, so schematic based will take the more time compared to the HDL. If you have a larger design, if you enter in the VLSI industry, the simulation will run 1 month, 2 months, 15 days, 20 days like that. Okay, because of that, a large circuit is there, large design is there. Right now, I made here only inverter. This is the small design. Okay, so if you run from a schematic, yeah, HDL, no issue, approximately. But here, I mean, what I am trying to tell here, the schematic based design and HDL based design compared to schematic, HDL design is faster. Okay, that's why we need to model everything. Okay, so I hope you will get the basic idea about that. And in the next part, I will discuss the syllabus overview. And please watch one by one and I am sure, I'm 100, I am 99.9% sure. just just promise with me, take this course and study one by one and make one note. And the free simulator also, I will explain in the next, in the upcoming part. And you need to write the very log code one day definitely. Whatever the digital circuit you study, just forget, I mean, whatever thing I explained already, this is the basic part and introductive part. Actually, I want to give idea. Just remember this thing. If you want to implement any digital circuit, okay, for hardware, as a hardware implement, you want to implement as a hardware, so you should have a standard language, that is the Verilog HDL. So with the help of the Verilog HDL, you can implement this thing. So so for that you should have an idea of the Verilog language. Okay, so I will start in upcoming video, and definitely you have an idea. And one day you will write the code of the any digital circuit, like encoder, decoder, mux, flip flop, counter, anything. Okay, shift register, like that. So thank you. The next part we will meet, and yeah, thank you.